Hello everyone, welcome back to Let's Unbound. We are in 10th episode of the series, which is Trigonometric Equation and Inequalities. So, um, at the starting of this playlist, right, we have come across reference angle, coterminal angles, ASTC, unit circle. So, all this will be applied in solving trigonometric equations and inequalities. So, it's very important. So, pay attention from the beginning until the end. Do watch the video completely. So, also be ready with pen and paper. Here we are into what is this trigonometric equations and inequalities? Generally, we know equations and inequalities made up of simply variable, but here it is going to be instead variable x, it can be sine x, sine theta, like cos x, tan x. Trigonometric functions will be involved, right? And x is usually angle. Generally, we'll solve for angles. Either it's an equation or it's an inequality, right? That simple it is. So, but let's see how this, yeah, of course, trig equations, it's not that simpler as we did in our algebraic equations and inequalities. So, we will be solving three problems and you might get uh, how to approach. You might get that concept and also how to approach a problem when you face an equation solving involving trigonometric steps. So, first general step is this. Isolate the trigonometric function. So we should simplify a trigonometric function and try to make it single trigonometric function, even though it's multiple included. We should able to make it single trigonometric function on one side and other side number. Find general solution using inverse trigonometric functions. Because we are finding angle, we have the ratio. That is how the situation will be. So we'll apply inverse trigonometric functions. And for general solution, for one revolution, like for one period, we can use unit circle that for two. But for like general means I can do many thousands of rotations if I want. Like the period, like I can do many. So we will use periodic property if they're asking for general solution. Consider all possible angles in a given domain. And also sometimes they won't ask you general solution. They will just give some restriction and we need to solve within that. So we should consider all the possibility. Apply periodicity to write the general solution. So this is important. When you're writing general means they will ask you find all values of an equation, right? And in that case, we should represent general solution. And this is the steps and now. Sometimes we will come across cosecant, secant, cot So we will manipulate them. Cosec is 1 by sine, secant is 1 by cos, cot is 1 by tan. In that way, we will manipulate this and then we will generally we know a lot about sine cos tan then cosecant secant and cot. That's why we are just manipulating this way our known three prime functions, right? And unit circle solving is something, so you might get sine x you isolated and you got something like 1 by 2. So in a unit circle you will draw, otherwise you can easily memorize when sine will be 1 by 2 when x is 30 degree. In that way also you can do, or you can draw the graph. This is x, this is 1 by 2 means or at opposite by hypotenuse 1 2 and work out this. And wherever sine x will give positive 1 by 2, here also it will give. So we will find that angle using ASTC. So this angle is generally theta. This is just reference angle first you will find. Then every quadrant is possible, right? So this quadrant it will be pi minus theta, right? So the theta is actually 30 degree. In such way we will find, or pi by 6. And then we will do the manipulation. And if a general solution, I will add 2 pi n with your solutions. Maybe 1 or 2 or 4, whatever. General solution means with your solutions add 2 pi n. If it's a cosine or sine function. If it's a tan function, you will just add pi n. Okay, because the periodicity. This is how we apply periodicity for general thing, general solution. And also we will use these values. If you memorize this, that will be great. Otherwise, it will consume time. So like we have to construct the triangle, input the values, apply Pythagoras theorem. Then you should apply ASTC like this, right? So to save the time, these are quite simple. When you practice a lot, you will get automatic. It will be automatically memorized, right? Now, let's solve some questions. Find all the exact value of sine x is equal to root 2 by 2. So whenever you see this, you should know it's 45 degrees. Sine 45 will give you something like this. But is it only 45? They ask you all exact values. And it's better to give your answers in radians. So first you draw the unit circle. Okay. Draw the unit circle. And okay, this is kind of smaller. Right. So now you take first quadrant only. This is just for reference, right? It's not only in first quadrant, it can be in second quadrant also. Correct? Because sine x is positive in this and this quadrant. So I'm drawing this. Sine x is adjacent. So if this is your x, is opposite over hypotenuse. Opposite is root 2, hypotenuse is 2. Then what is this? This is also root 2. It is 90. Isosceles means your x is 45. So x is 45 means pi by 4. This is not the final answer. This is just for reference. Okay. So whenever you see this, it's something deals with pi by 4 or multiples of pi by 4. Now, how can I find the exact values? Can you see one thing? Sin x and the ratio is positive. Possible in two quadrant. Here, your reference angle itself is the answer. Here, pi minus reference angle is the answer. Right? So, you're in like in first period, you can see x is equal to pi by 4 or pi minus pi by 4, which is x is equal to pi by 4 or pi minus pi by 4, you just cross multiply 4 times pi, 4 pi minus 1 pi, it's 3 pi by 4, right? So this is our x value we got here. And okay, but it's not all values. What if I do second rotation? I will be placed here, but it will be not pi by 4 and 3 pi by 4. It will be after 2 pi revolution. So it will be pi by 4 plus 2 pi or 3 pi by 4 plus 2 pi. After one rotation, I'm getting the same value. So you can just do many rotations, as many rotations you want, even the anti-clockwise or anti-clockwise. So the general solution will look like your x is equal to pi by 4, your period, sine means sine has a period 2 pi and n. Your n belongs to z. It can be 0. A0 means at the first rotation itself, before completing the first rotation. If you give 1, after completing first rotation, where I will get these values, right? And also negative also. MZ means what? You can give negative 1 also. Negative 1 means I'm doing this reverse way of rotation, right? And that's simple. So, okay, actually I did 1 and also 3 pi by 4 also will be x is equal to 3 pi by 4 plus 2 pi by n. Infinitely many solution and we represent in this like this way, right? That's question number 1 and next one, question number 2. Solve tan square x equal 1 in the interval 0 to 2 pi. So we have a restriction. It's not a general solution. This is restricted domain. So it's already your trigonometric function is isolated. So what is tan x? Plus or minus 1, right? Now you got two branches. Tan x is 1, tan x is negative 1. So whenever you see tan x is equal to 1, it's something deals with pi by 4. So reference angle is pi by 4. Okay. First, let me solve tan x equal to 1. So tan x equal to 1 in the sense, in first quadrant, tan will be positive. Okay, let me put it here. In first quadrant, tan will be positive. Also in the third quadrant. Okay. So we can just put it like this. So, and we know this quadrant it's positive, also this quadrant it's positive, right? So tan x equal to 1 in the sense your x is going to be First quadrant, your reference angle itself the answer. Third quadrant, how will you write? Pi plus your reference angle, right? So pi plus pi by 4. So your x is going to be pi by 4, or when you simplify this, 5 pi by 4. Just I solved one equation. Other equation also I should solve, which is tan x equal to -1. And reference angle is same for this because I don't care about sign. I'm just looking at the ratio. So one can be attained in tan function at pi by 4. So x is pi by 4. Then what? Also tan x is negative here. Also negative here. This angle you can write pi minus your reference angle. This is 2 pi minus your reference angle. Here reference angle itself. So another x is, okay, this is just a reference angle, not x actually. This is just reference angle. Now actually your x is negative. Tan x is negative in this quadrant. So like you have to do it this way. Pi minus theta reference angle. Pi minus pi by 4, which is 3 pi by 4. Then x is another negative is in this quadrant, and you can write something like this. 2 pi minus reference angle, 2 pi minus pi by 4. So 8 pi minus 5, 7 pi by 4. That's it. So I got 4 answers. Can you see it? And you have to check whether it falls into your domain. If it's out of your domain, you can just neglect it. Pi by 4, 5 pi by 4, 3 pi by 4, 7 pi by 4, all lies within the domain. 8 pi by 4 means it will not in domain because 8 pi by 4 is 2, right? So your x values are pi by 4. You can write an order also. 3 pi by 4, then 5 pi by 4, then 7 pi by 4. So these are the solutions. Particular solutions, we are just working on a restricted domain. Okay, hope this is clear. And with this, we are moving into next question. Solve the inequality for the restricted domain 0 to pi, and this is the inequality. Right. So first you should isolate your trig function. So I will add 2 on both sides. So this I'm writing here 2 cos x minus, wait a second, x minus pi by 2 is lesser or equal -1. And you divide by 2, you will get cos x minus pi by 2 is lesser or equal -1 by 2. X minus pi by 2 is lesser or equal cos inverse -1 by 2. Okay. Cos inverse -1 by 2 means what angle it is. Cos and it's negative. Cos is negative here and here. Okay. And 1 by 2 means cos inverse 1 by 2. I'm not taking sine because sine will decide which quadrant I should pick. Reference angle is, it's pi by 3. Okay, 60 degree and it's pi by 3. So, cos inverse, like I will have two branches. X minus pi by 2 is lesser or equal. Cos inverse -1 by 2 is pi minus pi by 3 because here only cos negative, not here or not here. And this quadrant will be theta minus reference. This is your reference angle. Pi minus pi by 3. And you can solve for it. X minus pi by 2 lesser or equal 2 pi by 3. X is less than or equal to 2 pi by 3 plus pi by 2. And x is less than or equal to, just cross multiply, 4 pi plus 3 pi, 7 pi by 6. Next, x minus pi by 2 is lesser or equal. How will you write this? Is pi plus theta r, like I mean reference angle. So it's pi plus pi by 3. X minus pi by 2 is less than or equal 3 pi, 4 pi by 3. Then you can take the pi by 2 here. X is less than or equal to 4 pi by 3 plus pi by 2. X is less than or equal 8 pi plus 3 pi, 11 pi by 6. So now I got two things, right? So this way, right? This way and this way. And when you graph this, the cos graph will come like this and then go like this. So first quadrant, second quadrant, third and fourth. So it should be 11 pi by 6 and 7 pi by 6 less than or like it is in between. There only it will be lesser or equal satisfied. Otherwise, it will be above. So though you got something like this, so we won't like we got a value, right? But which one will apt for? So that we should pick it from here. 7 pi by 6 to 11 pi by 6. Cos will be negative means here it will become negative, right? Like below x-axis. So this region is your answer. So x belongs to 7 pi by 6, comma 11 pi by 6. That's simple. This answer is. And that's it for today's lesson. And I have a bonus question. Take a screenshot and solve this. You treat this as a quadratic equation and you will get two factors, two equations. You solve them for the restricted domain, right? So one single clue I can give you. So sin x equal to some h or something. So you will get 2h square minus 3h plus 1 is 0. And then you factorize, then you put back, instead h, you put sin x, right? So try this. This is simple. And comment your doubts, queries, feedback, suggestions, anything in the comment section. We would like to hear it from you. So that's a wrap for today's video. Thank you for joining. I will be meeting you in next video very soon. Until then, keep learning and keep practicing. Stay curious.